Welcome back to our Culvert Inspector training video series. Get ready to explore deeper insights and more detailed characteristics. Let's jump right in. Let's keep exploring the type of location that you can mark during an inspection. Last time, we talked about the inlets and outlets. Another type of location that you can find is a drop inlet. These are concrete structures with grates where the flow enters into a concrete chamber connecting to a culvert. There are three types of drop inlets. The medium drop inlet, or MDI. They are placed in road medians or location outside of traffic. Then we have the shoulder drop inlet, or SDI. They are the same size as the medium, but are designed to withstand impacts from moving traffic. And finally, the curb drop inlets, or CDIs, and are distinguished from the other drop inlets in the opening of the side of the curb, called the sweep. For all drop inlets, do not measure the exterior dimension. Instead, measure the dimension of the culvert inside, if possible. Now, I suggest you to pause the video so you can review these diagrams and understand in a better way how the drop inlets are configured. Slot drains are metal culverts with a narrow gate placed above, usually along a highway curving. The pipe associated comes in 18 or 24 inches diameter. Try to measure by placing the tape measure in the slot and put the value into rise. Turnouts or driveways. This location is used for culverts crossing US and state roads, private drives, or commercial sites. As we mentioned in another video, a triple orange reflector T-post can be found, but sometimes there is no culvert. In those cases, geolocate the post, mark the location as triple orange reflector, and take a picture of the post and include some background information. Other location options are irrigation, when the culvert is used to water crops, or other in cases where the location doesn't fit in any of the previous options. The most common shapes used by the NMDOT are box, circular, arch pipe, and elliptical. Sometimes circular culverts get deformed over time, so be careful while selecting the shape of the culvert. And the most common materials are corrugated metal, concrete, plastic, metal, timber, which is very rare, and other. Another important characteristic of culverts are the end sections. We are used to improve the flow intake, protect the culvert, and improve the safety of the traveling public. Examples like this are defined as no end section. A metal or concrete end section has a flared shape to improve the flow of water. Head walls are vertical concrete structure placed at the end of the culvert. This only applies for circular, elliptical, and arch pipes. It shouldn't be confused with the parapet of a concrete box culvert. Sometimes head walls may have wing walls. If that is the case, the end section is a head wall with wing walls. Sometimes concrete box culverts, or CBCs, may have an apron or not. But wait, what is an apron? The apron is the concrete floor between the wing walls. Another type of end section is the concrete slope blanket, which are a slab of concrete placed at the inlet or outlet, and culverts are usually cut to match the slope of the blanket. Safety grates. Safety grates like these can be placed to prevent vehicles of overturning into the slope below. The geolocation point can be also an MDI, SDI, or CDI, like the ones mentioned before. And if you haven't found any of these end sections listed before, just select Other. Cool, we already know the shapes that the culverts can have. Notes, let's learn the measuring process. The diameter of a circular culvert comes in 6 inches increments. For elliptical and arch pipes, the measurement depends on the manufacturer, but measure to the closest inch for span and rise. For multi-barrel culverts, measure the width from end to end to the closest 0.1 foot. Remember, use inches for span and rise and feet for the width. For the CBCs, the span and rise comes in increments of 12 inches. In most instances, measuring one barrel will be enough. The skew and degree of skew. Let's change the perspective. Another characteristic of culverts is the skew, that basically is the orientation of the culvert to the direction of the road. If the culvert is oriented perpendicular to the road, its skew is normal. But when the culvert is not perpendicular, we need to define if it's skewed right or left. To achieve that, let's position ourselves parallel to the road. By extending our arms, we can replicate the alignment of the culvert. If you try to do it with the other arm, it is not possible or it's very uncomfortable. In this scenario, the culvert presents a left skew. When traveling in the opposite direction, you will notice that the leftward skew persists in orientation. Estimate the degree of skew visually, rounding to the nearest 22.5 degrees. It is time to talk about erosion control. These structures limit the power of fast-moving water, reducing channel erosion. Right here you can see a wire-enclosed riprap pad. Now some gabions and loose riprap, but in some cases you can find grouted riprap. If you are not able to find the erosion control, select Not Evident or None. In some cases, there are concrete structures like this one. But if the erosion control doesn't fit any of these categories, you already know what to do. Select Other. As you can see, as a culvert inspector requires much more than what you initially anticipated. We already reviewed the material and shape of the culvert, the location and the end sections, and more. Now, let's identify the channel types. Until now, there are 7 types of channels that we can identify in the field. The easiest case to identify is when there is no channel, or if there is running water. A dry arroyo is considered ephemeral because only runs during heavy rains or specific seasons, and you will identify it by seeing sand or gravel beds with vegetation in floodplains. Select roadside or median ditches if the primary drainage is from within the right-of-way of the road. If you see a concrete structure like this one, you will select concrete or asphalt line. If you notice that the channel is used to water crops, then select irrigation. As we always mention, if the channel doesn't fit any of these categories, mark it as Other. But wait, there is more. In addition to the type of channel, we have to specify the condition of it. So we will describe the general health of the channel. It can be good, dry and heavily vegetated, or swampy and heavily vegetated. Maybe it has weeds and debris, or even the channel is degrading. But hey, we're missing something important, the scour, which is the removal of riverbed material at the outlet of culverts due to high velocities of water. This is very common at the outlets with no erosion control structures. To get the depth of the scour, measure from the invert of the culvert to the bottom of the scour hole. If there is an erosion control structure, measure from the top of the structure to the bottom of the scour hole. Depending on the depth of the scour, we can classify it as little or no scour if it's less than 1 foot, minor scour for depths between 1 and 3 feet, major scour for depths between 3 to 8 feet, and severe scour if there's more than 8 feet. Now we're almost finished with the characteristics that a culvert inspector needs to check, and the next ones are probably the most important. The physical condition of the culverts. These are categorized as the damage and corrosion of the culvert, and the level of it will depend on your judgment as inspector. Let's talk about physical damage first. For metal culverts, we can find minor, moderate, and heavy damage. I'll give you a hint. If the pipe opening is significantly deformed, it can be moderate or heavy damage. For concrete culverts, you can select circular pipe damage, spalling, that is when a concrete chips or flakes away from the structure, with no exposed river, or severe spalling when you find exposed river. Spalling and cracks on the head walls or the apron, and severe cracks that are more than 1/4 of an inch, and others. If you're inspecting a group of culverts and you find different physical condition, select the worst. For the metal culverts only, the corrosion can be identified as not evident when the pipe is clean of corrosion, minor if the corrosion is only in or out of the pipe, moderate if the corrosion is in and out of the pipe, and major if the pipe is completely corroded, and unknown if you are not able to detect the corrosion. Finally, but not least, siltation occurs when the carrying capacity of flowing water is less than the amount of silt being carried. A culvert can be completely clean, or it can present minor silting if it's less than 10%. It can have 10 to 30%, 30 to 60, 60 to 90, or more than 90% of silting. I know that this is a lot of information, but when you get to the field, everything will make sense. That's it for this video, and I'll see you in the next one.